Welcome to day 8 of the Integral Calculus course. Today we're going to begin the study of derivatives. We're going to begin with the geometric interpretation of the derivative. We're going to think about the derivative in geometric terms. We're going to present this concept of derivative. To do that, we need to review the concept of the slope of a line. We're going to do that, and we're going to graph this line here, and let's try to define what will be the slope of this line. To define the slope of a line, what you do is you take a number a on the x-axis, and then you take another number b on the x-axis. You consider the values of the function at these 2 points. This will be a f of a, this point. This other point will be b f of b. And we define delta x and delta y at these 2 little segments here. Delta x is a change on the variable x, and delta y is a change on the variable y. And we define the slope of the line as delta y over delta x. This is how the slope of a line is defined. In this case, delta x equals v minus a. And delta y, that is because, well, this segment is b minus a. And delta y is this height minus this height. But this height is f of b, and this one is f of a. So delta y equals f of b minus f of a. If we replace these two in the definition of the slope, we get this formula. And this formula will become very familiar to you because we're going to use it quite a lot when calculating the derivatives by definition. So the concept of derivative arises when you try to generalize this concept to any curve that is not a line. How can we define the slope of a curve that is not a line? For example, let's take this curve f of x equals x squared. This function, the graph of the function is a curve. How can we define the slope? The natural thing to do is to try to do something similar to what we did with a line. We're going to take a point x0 here in the x-axis. We're going to take another point that we're going to call x0 plus delta x. This is just another point. Delta x is a number. We're going to consider the values of the function at these 2 points. This will be f of x0. This will be f of x0 plus delta x. And we define delta x and delta y as these 2 segments here. Well, we already defined delta x as this segment when we took x0 plus delta x. And delta y is this segment. And now we take the line that intersects the graph at these 2 points. We call this line the secant line. And if we take delta y over delta x, this is how we define the slope of a line. Delta y over delta x is the slope of the secant line, of the purple line here. And in this case, we can calculate delta y as f of x0 plus delta x, that is this height, minus this height, that is f of x0. So this is the slope of the secant line. But we're not really interested in the slope of the secant line. What we want is the slope of the curve. And the reality is that curves don't really have slopes. But what we can do is to take the slope of the tangent line. And to do that, what we do is we take delta x smaller and smaller. And we even take the limit as delta x approaches 0 of this quotient. So let's see what happens graphically when delta x approaches 0. Here we have the secant line, here we have delta x and delta y. And if we take delta x smaller, we get this graph. If we take delta x smaller, we take this graph. Even smaller, we have this. And if we continue like this and we take the limit as delta x approaches 0, we see that the secant line becomes a tangent line. A tangent line is a line that touches the graph only on one point. That's a tangent line. So if we take this quotient here without the limit sign, is the slope of the secant line. When we take the limit, what we get is the slope of this tangent line. And that's how we define the derivative. We define the derivative of the function of this function at this point x0, and we write it like this, and this is read f prime of x0 as this limit. This is the limit of the slopes of the secant lines when delta x approaches 0, and this equals the slope of the tangent line at that point, and that's the derivative. This is how you should always think about the derivative as the slope of the tangent line. So in the next videos we're going to talk about another ways of thinking about the derivative. There are other ways you can think about the derivative. So that's all for now. Thank you for watching and see you next time.